Imagine you are sitting for an interview and the interviewer gives you a dataset that contains missing values, duplicate values, inconsistent data like wrong data types and invalid entries. And he asks you to clean this dataset and explain each and every step. As cleaning of the dataset is very essential for further data analysis. What would you do? By the end of this video, you will able to understand how data scientists handle missing values, wrong data types in a messy data and cleans it into a clean data. Hello everyone, I am Viren and welcome to my channel Data Science Decoded. On this channel, we will simplify data science, AI and machine learning concepts. The question here is, why data cleaning is important? Real world data is often really perfect. Using this messy data while training a machine learning model can lead to inaccurate predictions. Due to these inaccurate predictions, we can get inaccurate results. That's why data cleaning is very important. In this video, we will learn about data cleaning and how it is done through real-world example and coding. Before we start cleaning the data, we first need a dataset. In this video, I will use a real-world dataset from Kaggle, one of the most popular platforms for data science and machine learning. Kaggle provides thousands of free datasets created by companies, researchers, and the data science community. These datasets are widely used for learning, projects, competitions, and even interview practice. Now, let's click on the datasets section. Here, you can search for datasets based on your project or the topics you want to learn. Today, I will use house prediction system because it contains different types of real-world data and is perfect for practicing data cleaning. Now, let's go with this house prediction dataset. Before downloading, always take a quick look at the dataset description. It tells you what the dataset is about, the meaning of each column, and where the data came from. Understanding the dataset before analysis is a good habit for every data scientist. Now, let's download the dataset. Simply click the download button. Now, the dataset is being downloaded. It would take around 10 to 15 seconds to download. Let's open it and take a quick view. Now you can see there are various columns. We will use these columns for data cleaning and data analysis. The first step is to import the Pandas library. Pandas is one of the most important Python libraries in data science because it helps us to load, clean, organize and analyze data sets. Here, I have imported pandas using the alias pd. Instead of writing pandas everywhere, we can simply write pd, which makes our code shorter and easier to read. Step 2. Read the CSV file. Now, let's load our dataset into Python. The read CSV function reads the CSV file and stores it in a data frame. A data frame is a two-dimensional table with rows and columns, similar to an Excel spreadsheet. I have stored it in a variable called df, which is a common abbreviation for data frame. Step 3. Save the dataset. Using toCSV function, we can save the dataset. The parameter index is equals to false ensures that the data frame index is not added as an extra column in the CSV file. We can save the name of the file according to our need. We can rename it and we can store the file according to the place we want to store in the computer, like in C drive or D drive, according to the needs. Let's do data cleaning. First, let's load our dataset into Python using Pandas. This stores all the data in a data frame. Next is df.head. Before cleaning the data, let's first look at the dataset. The head function displays the first 5 rows, giving us an overview of the columns and the type of information available. These are the first 5 rows. Next is df.info. It tells us total number of rows and columns, the data type of each column, and most importantly, whether any column contains missing values. Next is df.describe. The describe function provides a statistical summary of all numerical columns. It shows values like count, mean, minimum, maximum, and quartiles, helping us understand the distribution of our data. Next is checking missing values. From this step, data cleaning starts. df.isNull.sum. The isNull.sum function counts the number of empty values in each column. Before filling missing data, we first need to know exactly where those missing values exist. Like in this, there are 5 missing values in age, 2 missing values in preferred tenant column, 7 missing values in locality rating, and 6 missing values in the column that is price. Now we will fill the missing values. The age column contains missing values. Since age is a numerical column, please remember the difference between numerical column and the categorical column. Now age is a numerical column. We will replace those missing values with the average age. This helps to preserve the overall distribution of the data. The preferred tenant column is categorical, so we will use the mode. We can't use mean, median. Mean and median are used for numerical column, while mode is used for categorical column, which means the most frequently occurring value. This is a common approach for filling missing values in a categorical data. For the locality rating column, we will use the median instead of the mean. The median is less affected by extreme values and often gives a better representation of the central value. All the missing values are filled with the function fillNow. FillNow function fills the column according to the statement. Like in the next, we will fill the price column. Since prices can vary significantly, the median provides a more reliable value than the average, so we used median in place of mean. So, using fillNow function, the missing values of price column has been filled by the median of price column. Now, we will check using df.isNull.sum again if all missing values are filled or not. Here, all the missing values have been filled and our data set looks much more complete. Next is checking duplicate records. As duplicate rows can create bias in our dataset, and this biased data is not suitable for data analysis and machine learning models.
So it's important to identify them before moving forward. So we wrote duplicated.sum, which gives us the sum of all duplicate values. So it is showing 0. So there is no duplicate values in the data set. Now checking for the inconsistent city names. We will write print df.city.unique. This gives us the city names. People write city names in different ways due to different naming conventions. Some write the whole city name in uppercase, some write in all city names in lowercase. We have to make it consistent, so that will be very easy to analyze and will be very beneficial for machine learning. Now, for df city column, we will use str.strip. What does str.strip does? The strip function removes those unnecessary spaces and makes the data more consistent. Then str.lower. str.lower converts all city names to lowercase. Sometimes the same city is written with different spellings due to typing mistakes. For example, Bangalore is an incorrect spelling of Bangalore. If we don't fix this, Python will treat them as two different cities during analysis. So we will use str.replace function to replace the correct spelling with the correct one and make our data consistent. Next is removing extra spaces. In some datasets, text values may contain unnecessary spaces. These spaces can create inconsistencies while filtering or grouping the data. Using str.replace, we remove all spaces from the city names, making the data cleaner. Now, let's check whether our dataset contains any invalid age values. In this project, we will consider any age less than 1 year or greater than 100 years as invalid because these values are unrealistic for our analysis. We created a new variable as invalid age and we filtered out ages less than 1 year and greater than 100 year, and we used an OR operator between them. So when we print the invalid age, we get to know that some records have an age of 0 while others have values like 121 and 438. These are clearly incorrect and need to be corrected before we continue. Now, we calculate the median age. Instead of removing these records, we will replace the invalid ages with the median age calculated from all valid age values between 1 and 100. So we created a new variable as median age. So it filtered all ages equal to or greater than 1 and equal to and less than 100, and we put an AND operator between them, and we used median function. We use median because it is less affected by extreme values and provides a more reliable replacement than the average. Now we will replace invalid ages. Now we will update the dataset. The loc function is used to access or modify specific rows and columns based on labels. Now this is the condition. It checks every row and selects only those where the age is less than 1 or greater than 1. After the comma, we specify the column we want to modify. In this case, only the age column will be updated. Finally, we assign the median age to all those selected rows. Let's verify. whether all invalid age values have been corrected. We run the same condition again, and this time the result is an empty data frame. That means there are no edges below 1 or above 100 remaining in the data set. Our age column is now clean and ready for further analysis. Now, we will perform the same validation for the locality rating column. Since locality ratings are given on a scale from 0 to 10, we created a new variable as invalid locality rating. So any value below 0 and above 10 is considered as invalid. We filter it out, and using this condition we display only the rows containing invalid ratings. As you can see, values like -5, 67 and 99 are clearly incorrect and need to be corrected. Instead of deleting these records, we will calculate the average of all valid locality ratings between 0 and 100. We will use this mean value to replace the invalid ratings so that we don't lose any valuable data. Now, using the loc function, we will select all the rows with locality ratings that are invalid and replace with those values with the mean rating we just calculated right above. This corrects the data while keeping all the records intact. Now we will verify the result, and this time we get an empty data frame that confirms all invalid locality ratings have been successfully corrected. In this way, the basic data cleaning steps can be done. These are all basic data cleaning steps. In the next video, we will learn about how advanced data cleaning works.
In this way, data can be cleaned and further used for exploratory data analysis and model building. Thank you for watching, and don't forget to like and subscribe my channel. Follow the journey and let's become data scientists together.